Before DDR RAM existed, computers used something called SD RAM. And honestly, it was slow, like click one program, wait, open another one, wait again. Back then, memory could only move data once per clock cycle, which meant even simple tasks could make your computer feel like it was dragging. Think of it like this. Imagine your CPU is a chef in a busy kitchen, and SD RAM could only hand over one ingredient at a time. That was old memory. Everything felt slow. Programs took forever to open, and multitasking almost impossible. Then, around the year 2000, DDR1 arrived. Memory basically doubled its speed. DDR literally stood for double data rate, meaning instead of transferring data once per clock cycle, it could now transfer it twice, which was a massive deal back then. Suddenly, computers didn't feel like they were crawling anymore. Systems became smoother. Games like Doom and Counter-Strike felt, for the first time, responsive. But here's the problem. DDR1 consumed a lot of power. And more power meant more heat. When that memory overheated, your computer could freeze, crash, or completely lock up. It was even worse because DDR1 existed during the era of Windows Millennium Edition, arguably one of the most unstable versions of Windows ever made. But then, RAM manufacturers set out to solve that problem. That led us to DDR2. DDR2 launched in 2003 with a promise: more speed, less power, better efficiency. Sounds perfect, right? Not exactly. DDR2 was technically faster, but sometimes it felt slower than DDR1. The reason? Latency. Think of it like this. DDR1 was like a small car. It could start moving instantly. DDR2 was like a massive bus. It carried more people, but it took longer to get moving. For lighter tasks, DDR1 sometimes responded faster. But for heavy workloads, DDR2 absolutely destroyed it. Voltage dropped from 2.5 volts down to 1.8. Heat improved. Capacities reached up to 4 gigabytes per stick, finally making multitasking feel smoother. You could open multiple browser tabs without your system freezing like a statue. Well, most of the time. Because as software became heavier, even DDR2 started struggling. Games became more demanding. Multitasking still wasn't perfect. People started wanting even more performance, not just for work, but for gaming. And that is where DDR3 changed everything. DDR3 arrived in 2007, and honestly, this is the RAM generation most people remember emotionally. If you built a computer between 2008 and 2015, there's a very good chance you used DDR3. Compared to older memory, this was a huge leap forward. Voltage dropped to 1.5 volts. Systems ran cooler. Laptop batteries lasted longer. But the biggest improvement? Dual-channel memory. Instead of one RAM stick moving data alone, two could work together. Think of it like having two hands instead of one. You can carry more at the same time. And for gaming, this mattered a lot. But DDR3 had its limits. Even though the RAM was faster, computers still sometimes felt heavy. And the culprit? Windows Vista. Again, it consumed massive resources, and games like Crysis were brutal on hardware. And honestly, some people still use DDR3 today. If you're one of them, don't rush to replace the whole computer. A simple RAM upgrade can often make an old system feel surprisingly responsive. I've linked some solid DDR3 kits below if you want to check them out. DDR4 launched in 2014. But here's the dirty secret. At first, nobody cared. DDR3 was good enough. Early DDR4 was expensive, barely faster in games, and required new motherboards. Reviewers called it unnecessary, and for a while, they were right. Then, AMD released Ryzen in 2017. Suddenly, RAM speed mattered a lot. The faster your RAM, the better your gaming performance became. Overnight, DDR4 became the industry standard for video editing, streaming, gaming, and programming. Now, 8 gigabytes is the bare minimum, but 16 gigabytes? That's the sweet spot. If you stream or render videos, 32 gigabytes starts making sense. But here's the myth. More RAM does not always mean more FPS. If a game only needs 12 gigabytes, going from 16 gigabytes to 64 gigabytes changes nothing. At that point, it's just expensive decoration. If you're building a gaming PC today, a good 16 gigabyte DDR4 kit is one of the best value upgrades you can make. Links below. That brings us to the future, DDR5. DDR5 arrived in 2020. This wasn't built just for gaming. It was built for the future, AI workloads, 8K editing, and massive multitasking. DDR5 pushed speeds beyond 4,800 MHz, then 6,000, then even higher. It introduced ECC, error correcting code, to detect and fix data errors automatically, and dual subchannels to process streams of data more efficiently. But here's the honest truth nobody tells you. For most people, DDR4 is still enough. If you own a strong DDR4 system, upgrading everything for DDR5 might not be worth it yet, because it requires a new motherboard, a new CPU, and a much more expensive upgrade path. However, if you are building a brand new PC in 2026, DDR5 is the smarter choice. I've left the best value kits down below, and honestly, DDR6 is already on the horizon, which is terrifying because technology moves ridiculously fast. And there you have it, the insane evolution of DDR RAM. From slow, struggling PCs to the lightning-fast systems we use today. Hope you enjoyed the video, and trust me, the next topic gets even crazier. I'll see you in the next one.